Welcome everyone to Data Virtualization in Action, Scaling APIs and Apps with FME. Today, we have the pleasure of being joined by our good partner, Dennis, over at Terra in Germany. So excited to hear from him today and hear more about their API templates with data virtualization. So I'll pass things over to Dennis to introduce himself first.
Yeah, thanks again. As we heard, my name is Dennis. I've been with Terra for over 10 years now, working mainly with FME as a software engineer and a software architect, and done a lot with FME. And yeah, we are a big partner of SAFE since ages, I guess. And we spent a little bit of time getting to know the data virtualization news and have been working on some templates that I'm going to show today.
Awesome. And over to Rylan.
Hello, everyone. I've been at SAFE for just over 10 years now. I work as a group product manager, and my day-to-day responsibility relies in FME Flow. So data virtualization, what we're presenting on today, I've had the privilege of working on very closely.
Awesome. And Nick.
Good morning. So my name's Nick. I am a product manager for our cloud products here at SAFE. So that covers Flow Hosted, FME Hub, FME Account, a bunch of other sort of behind the scenes products. I don't work directly with the Flow team on products like data virtualization, but I've been a long time FME user and I was very excited to play with it when it first came out.
Fantastic. Thank you so much, everyone. Okay, so just briefly here before we dive into today's webinar content, if you are newer to our webinar platform, I'll take you through some quick tips and tricks here. So if you do have any audio or video issues during the webinar, please click that help button on the bottom left for 4 simple steps to take. You can share your emoji reactions with us during the webinar. We love to see those. It really fuels our energy. We love to see how you're reacting to the content as we go. So please do feel encouraged to use those emoji reactions. Questions. So we will have some dedicated time at the end to address questions live, but then also we should be able to get to some as we go along. So feel free to drop any questions that you might have into that questions tab and we can reply there. And then lastly, our chat. Keep letting us know where you're tuning in from or share any comments you have during the webinar there. All right, so at this point, I will prompt our presenters if we can turn off our webcams just to save on some bandwidth for the rest of the webinar here. And I'll go through our agenda briefly. So today, we are going to be kicking things off with an introduction to data virtualization and go through why data virtualization and the challenges you might face when getting started. From there, we will be passing things over to Dennis for his reusable API templates. I'm excited to learn more about those and give you guys some tools to get started. Moving on, we'll be going through API authentication and authorization, followed by what's new and coming up in the world of data virtualization in FME. And then we'll be wrapping things up with a summary and some resources and next steps to help you get started after this webinar. And then once again, our Q&A session. So do get questions in as we go along here. All right, and with that, I will pass things over to Rylan to kick us off with our introduction.
Awesome, thanks, Elizabeth. So we are diving into one of the most exciting capabilities we've added to FME, data virtualization. We first announced it at our user conference, the Peak of Data and AI, and since then, the response, I'll say, has been incredible. The production-ready release has been live for a couple of months now, and many of you have already started to explore what's possible. So this webinar builds on our first session. If you joined that one, you got a great overview. Today, we're going to go a little deeper. We'll walk through more advanced use cases, show you how to think about scalability and security, and explore how you can apply these APIs in real-world scenarios. What makes this really powerful is that it's all done using the no-code interfaces of FME Form and Flow. You don't need to be a developer to create real-time secure APIs. And if you are a developer, you'll appreciate how fast and flexible it is. Okay, before we go any further, I'm going to pop out into a Flash demo and quickly show you where data virtualization is in FME Flow. Up on screen here, I have my FME Flow dashboard, where you can see data virtualization is accessible from the side navigation menu. When I select it, I can see all of the APIs that I've created. In this case, I have 3, so FME Flow can power more than one API. You can create your own from scratch, or you can import from an existing open API specification. Let's take a look at this one that I've already created. I can see the list of all my endpoints on the left-hand side. If I select an endpoint, then I can see the details. I can navigate to the parameters, define any path, query, or header parameters that my end user accessing the endpoint would be able to define. The entire request body I have full control of. I can use schemas. I can create my own properties. And the power of data virtualization, of course, is in the response that it can deliver. I can have a static response, or in this case, I've selected to have an FME workspace generate the response for my data virtualization endpoint. There's additional configuration options you have here. You can see a list of all your FME workspaces that you have associated with your endpoints. There's a list of all of our schemas that we can have, these reusable schemas for different endpoints. There's a full security section and further configuration in API details like caching and asynchronous processing. So that's just a quick overview of data virtualization in FME. If you want more in-depth overview, check out our first webinar, but now we're going to get going with the content here. Data virtualization in FME lets you break down the traditional data silos. Instead of moving data between systems, you connect directly to it, regardless of where it lives. That means teams can access consistent live data across tools, apps, and platforms you already use without duplicating or syncing the data. It enables on-demand access, perfect for powering dashboards, web apps, or analytics tools where up-to-the-minute information matters. With centralized control, you can define exactly what data is available and to whom, enhancing both security and governance. So that's critical in complex environments with varying data access needs. And the best part, again, you don't have to write a single line of code. You can rapidly build, test, iterate in a visual, no-code environment. It also works seamlessly with Esri tools and enterprise systems. So you're not reinventing your tech stack. Instead, you're unlocking its full value. Now, before we dive further into how FME helps, let's acknowledge some of the common frustrations we hear from our users trying to solve these problems on their own, or even with other platforms. First, there's the classic issue of having to start from scratch. No templates, no examples, just a blank screen and some documentation to figure it all out. That slows everything down. Security is another big one. You want your data to be accessible in real time, but you also need to protect it, restricting who sees what, without creating a bottleneck for people who actually need access. Then there's performance. Maybe your setup works well for a few users or queries, but as usage scales up, dashboards refresh more frequently and more departments rely on it, you can hit some serious slowdowns. And let's not forget the challenge of working across multiple data formats or schema types, whether it's JSON, XML, spatial data, stitching that all together manually, no small task. Finally, visibility. You might have different teams or departments managing their own data endpoints, and suddenly you're flying blind. No central view, no governance, no way to manage it all efficiently. These are all real issues, and they're exactly the kind of problems data virtualization with FME was designed to solve. We've built FME's data virtualization with you in mind. You can create reusable templates or import existing open API specifications so you're not starting from scratch. There are tools to keep your data secure and performance features like caching or async execution to scale with confidence. All of this without writing code. Data virtualization is built right into the FME platform. No extra cost, no add-ons. If you're already using FME, you already have what you need to get started. FME Form, our no-code authoring environment, is where you design your data workflows. You can then deploy and automate these workflows with FME Flow, whether that's on-prem, in your private cloud, or in a fully managed AWS environment, FME Flow hosted. And we've recently introduced FME Realize, a mobile app that visualizes live data in augmented reality served directly from FME Flow. So whether you're designing, deploying, or delivering, the entire platform is built to support data virtualization, and again, with no additional licensing requirements. But to platform, it only matters if it can actually connect to your data. We started out focused on GIS and geospatial data, but over the years, we've grown with our users. Today, FME supports over 500 data types, from spatial data and real-time IoT to cloud-native formats and generative AI. Our goal is to help you use your data where, when, and how you need it, no matter where it comes from. This diversity of support is what makes FME a true enterprise integration platform and a solid foundation for data virtualization. So that's the landscape. Broad data support, flexible deployment options, and all capabilities built right into the FME platform. Now let's take a closer look at how data virtualization actually works in action. I'll pass it over to Dennis.
Thanks, Ryan. So as we mentioned at the beginning, I'm going to talk about templates that we have created, two of them about OGC APIs. And yeah, when we heard about data virtualization, we thought there were basically endless possibilities. But we also thought it might be a good idea to also implement existing standards to basically make it easier to integrate FME in IT infrastructures, because obviously standards mean that they might already be implemented. And I also mentioned OGC just now. OGC APIs are the first standards we thought about. So I don't want to go into detail for all of them, but basically there are APIs like the OGC API features. It's basically the newer implementation of the web feature service that you also might know, which is just access to vector data. We also have an API for map visualization, an API for execution and of processes and job management, for raster data access, and also for querying metadata. And OGC APIs matter because, as I mentioned, most applications already interact with them. So it's easy to integrate new systems into already existing modern web clients and services. And if you are building upon standards, then it also reduces vendor lock-in. So you can easily switch out individual elements and everything will still work in the future. And OGC APIs are already widely supported across geospatial ecosystem. So tools like Esri, QGIS, and of course also FME already implement some of these APIs. So we thought we make it easier to get started, and therefore we created a few templates for the FME Hub. One of them is for the OGC API features to expose live vector datasets, and the other one is for processes, because that's what FME is all about, starting processes online. And we try to do that using one of these standardized APIs. These templates are available for free on the FME Hub. You can simply download them as an FME project, you can import them, and the only necessary configuration you need to do is to provide your own FME Flow web connection. And of course, this is just an example implementation that can be customized for your own use cases. So yeah, if you like, have a look at them. Of course, I didn't develop everything on my own, so I want to also shout out to the team at Conterra, mainly Mitzi and Gunnar, who did a lot of the work, and they also deserve the credits. So OGC API processes is about wrapping computational tasks offered by a server through web API. I don't want to read the full definition here, but basically it's about starting processes online. And I provided a list of all the endpoints that are necessary to have an API comply to the standard. And on the left, there are basically the endpoints provided by this standard. Like you can see there's a conformance API that just informs about what this API can do. There's a processes endpoint to retrieve all the available processes. And in the FME world, of course, this is just workspaces, right? So we have the description and parameters of all the workspaces that we need, and we can access all of them, but we can also query for individual processes. We also have an endpoint for jobs, which means we can list already executed jobs, which is exactly the same as an FME. We have an endpoint to execute individual processes, which is a post endpoint. And here it'll be a little bit more different on the FME side. We have data download, data streaming, and job submitter services for various use cases, like getting a zip file back, streaming data directly, or simply executing jobs. And we also have endpoints to retrieve the status of a job, get the result again for asynchronous jobs, and so on. So as you can see on the slide, the main concepts are pretty much alike. So it kind of made sense to build an API interface for this in FME. So the initial motivation for this also came from a customer. So Deutsche Telekom asked us a few years ago already to provide an OGC API processes interface for FME. And of course, back then we didn't have data virtualization. So what we did is we built a Python-based adapter that basically handled all this transformation between FME API and this OGC API. And of course, the goal now is to switch somehow to the FME functionality, basically data virtualization in the future, instead of having to maintain our own custom implementation over the next years. So the other template we provide is for OGC API features. Features, as I mentioned, is the old WFS service, and it provides the capability to create, modify, and query spatial data. So it's a standard way of sharing feature data and also accessing this data again. And the OGC API features also provides a few endpoints that can now be used through FME. So you can access vector data, and there are also ways to filter this data, for example, using the bounding box, datetime, or any sort of properties that might be available in the dataset. And we mainly thought about providing a way to access this data as vector data as an API, and basically not to replace existing map clients, because mainly most applications that are built for this might still be better. We only want to provide an API access right now. So if you have provided an OGC API features endpoint through FME, that also means that you can access this data now through FME again. So on the right side, you can see there's a feature reader simply using the OGC API features format. And by providing the URL, we can now access the data. And since it's also described in individual collections, it's also possible to get a list of all the feature types that might be existing on our FME flow and simply select them in the graphical user interface here. And then, of course, you can also do stuff in FME like providing spatial filters, clipping data, and all of that stuff. All right, so I'm going to show you now what we did in FME to get all of that working. And after that, I'm going to show a short demonstration. So the first step is to set up all of these OGC API processes endpoints. So we need the jobs endpoint, processes, execution, and so on. And for each of these, we need to create an API endpoint, and we also need to create an FME workspace. Within the individual FME workspaces, there is this new type of reader feature type that actually listens to these endpoints that we have defined. So in this screenshot, you can see our execution endpoint that has properties like the process ID, the process body, and so on. And of course, these parameters need to be processed. And for each of the processes that we have defined, we also have a definition that we are loading in here. And we're making sure that all of the input parameters are actually set correctly. The most interesting part is, I guess, to actually start FME workspaces again from our FME workspace. We've done that using various HTTP callers. And as I mentioned earlier, in FME, there's data streaming, data download, and there are multiple ways to execute workspaces synchronously or asynchronously. And of course, based on the individual parameters that we get from the input, we can decide which workspace execution we want to use in here. And of course, at the end, we also need to provide an HTTP response back. So this might be a 200 if everything was okay when we simply had a GET request. It might also be a 404 if the user inserted a process ID, for example, that wasn't available. And of course, you also need to handle all sorts of errors if the user input was just completely wrong. So, of course, there are other steps involved as well. And the main heavy lifting is basically mapping between parameters from FME and the OGC API, simply because the way how they are represented in the JSON format might be different. Then I just mentioned we need to trigger jobs using the different FME services. And we also implemented a custom job database to handle all the jobs, basically storing UUIDs that can reference to FME jobs. And also for providing data streaming, also as an asynchronous way, we needed a way to store this or store the data streaming results as well. And it's also important to provide metadata for all of the processes, like description, what is this workspace all about, which links are necessary to actually execute the processes later on. And as I mentioned, we've done all of that already for you in these existing FME Hub templates. All right, so let's see how all of that looks like in FME, and we are going to start the demo. So in the data virtualization overview, you can see all the endpoints that we have created already. And as I mentioned, for each of these endpoints, we also assigned a workspace. And once all of that is done, we can have a look at the interactive documentation that is available for all of the APIs. And this makes it quite easy to actually test these workspaces and just play around with it. And for the first one, we're just going to get all the processes that are available on our FME flow. And of course, there are quite a few information, but for now, it's only necessary to get the ID and the title of the process. We have just a short buffer process here. And it also tells us basically which input parameters are available. So for example, we need to provide a GeoJSON file, and we can also define a distance. So it's just, as I mentioned, a short example process to execute a buffer workspace. So the next endpoint is an execution endpoint. We can simply provide our process ID that we just fetched earlier. We can specify if the workspace is supposed to be executed as a synchronous workspace or not. And of course, we need to provide all of these parameters like the GeoJSON, geometry, and the buffer distance. And we can also specify how this result should be returned to us. In the OGC standard, this is defined as a transmission mode, and value basically means that we will have a data streaming, so we'll get the result right away. So we'll get our new GeoJSON file that we can use, for example, in another process. And we can now simply change a few values here, like switching from value to reference, which basically means we're going to do a data download. So we're going to get the reference to our result now as a zip archive, which is of course a native functionality that FME already has. And we can also specify to run all of that in asynchronous execution mode, which basically means that we will just get a job ID that can be used, of course, later on to fetch the result again. So we can just go ahead and copy this job ID and go to the last endpoint that we want to show today, which is basically the endpoint to get the result back. So this can be used as often as you want to. It's asynchronous, and you simply need to provide the job ID, and you can also get the link back. So that's just a short example on how to use one of these OGC APIs in front of FME. So I thought I might end with a little joke here, and I asked ChatGPT for a little bit of help. So writing your own API without standards is like cooking without a recipe. Sure, it might work, but good luck explaining it to anyone else. So the main idea why you might want to do something like that is, of course, if you only need to implement one single API, then it doesn't really matter too much which API it is. You can just figure it out and implement it. But if you're implementing a lot of different APIs for different services, for different systems, then of course, this time to get to know an API and stuff like that can take time. And this can add up. So if you have a standardized way to interact with systems like executing processes, getting data, and so on, then it might make sense to save a little bit of time and just work with existing standards. So people have already thought about how to create a good API. So it might be worth looking into these. And yeah, FME already provides all of these functionalities to execute processes, to provide APIs. And as you could see, it kind of looks different now from FME, but it's just another way how to interact with FME, and all based on data virtualization. So these templates that we have provided should make it a little bit more easy to get started without going through all of the full API specs, which can be quite long for the OGC. So you don't have to do that all manually. And hopefully this might help some of you. And yeah, feel free to ask any questions later on if you're interested. And with that, I'm giving back over to Rylan.
And I'll just jump in here and say, thanks so much, Dennis, for taking the time to show us those templates. Looks like the audience is eager to start playing with those and testing those out and making use of those already just based on the reactions. So really appreciate your time. I do want to highlight Dennis' email is on this screen. So if you do have any follow-up questions about the content he shared today. But of course, we will also have live questions at the end and during the remainder of the webinar. So please do get those into the questions tab. Fantastic. Awesome. Thank you so much.
All right. Thanks for having me.
Yeah, our pleasure. All right. Yeah, sorry. Back over to Rylan and Nick here.
Alrighty, well, I'm going to jump in here and I'm going to start talking a little bit about some additional functionality in data virtualization that always needs some consideration in every project that you're working on around API authentication and authorization. So we're going to talk a little bit about what they are and how they present themselves in data virtualization, and some thoughts, tips, and tricks that you can use to further enhance the security of the projects and the data that you're working with. The first thing I wanted to mention is what I'm about to talk about builds upon a couple of presentations that I have already done, mostly at the Peak of Data in AI back in May in Seattle. We had a plenary session where we introduced a project that I worked on around some travel and data virtualization integrations. And if you click on the link in this slide here, you'll be brought to you should go to the 53-minute mark, and you'll get a good high-level introduction of the project that I worked on. And then there was also a breakout session that dives into the deeper details of how data virtualization was used to build an API, how a front end was built to interact with it, and some of the pieces that go with that. Today, I'm going to talk about authorization and authentication in the context of this project, but you don't need to know a fair bit of background about it in order to get some good information out of today. So again, just a really quick refresher, I had built a project because I'm a giant nerd around travel. I like to go places, and I wanted an ability to sort of track and visualize the places that I have been, the places I want to go. And when data virtualization was first internally announced about a year ago, probably, I decided I wanted to use it to build out a fun little project and help learn the pieces that are involved in building a good project with data virtualization. And so this is the project I had built. Lets you track and manage the places that you had been around the world, if you're lucky enough to have been traveling a fair bit, and places that you want to go as well, and putting it all into a nice simple UI, but using data virtualization as the engine behind the scenes. So when talking about data virtualization, one of the most important pieces to securing your data comes around the concepts of authentication and authorization in data virtualization. Now, these terms are often used fairly interchangeably, but they do have some differences, of course, and have some important practical applications, especially when using data virtualization, that need to be considered. So first off, though, what is the difference, right? Authentication really just asks the question, who are you? You know, verifies the identity of the user, you know, a username and password combo, like a lot of websites, API keys, an OAuth token, a JWT token, whatever. There's a lot of different ways of saying, who are you? This is a really fundamentally important piece of the puzzle here, and allows you to ensure that the right users have access to your project or your data virtualization endpoints, or just your data in general. The second half of this comes around authorization. So a bit more nuanced here, but it asks the question, what are you allowed to do? So we know who you are, that's great, but what are you allowed to actually do? And this is a bit more of a nuanced concept, and there's a number of features and functionalities in FME Flow and data virtualization that let you determine that and decide how to proceed. So in a quick sort of summary here, authentication proves your identity, authorization controls the access to your data or to your processes here. So we've got some great built-in functionality that takes a lot of the hassles out of authentication within FME Flow. So for example, using the Flow user model, you can easily integrate authentication into your APIs. You can see here, quick examples of just how that works in terms of data virtualization. Right down to the endpoint level, you can decide whether you need authentication to get access. So as you can see here in the slides, the FME Flow lets you get strong control over who has access to your specific endpoints. You may have some endpoints that don't require authentication. You're returning a status, for example, and you can create those to be unauthenticated. But when you have endpoints that require interaction with your database or specific data sets, then you'll likely want it to be authenticated to help control access to it. So there's three main ways of handling authentication with a data virtualization project or endpoint. We have our no authentication option. So as you saw in the screenshot before, you may have an endpoint around metadata or a status that you don't need to gatekeep any of the access to, and so you use no authentication for that. The best and easiest way to help authenticate your workflows are using the FME Flow users and roles model, which we'll dive into as well. And then there is a bit of a hybrid approach where we can build our own custom authentication as well. And we'll talk more about that as well. First, though, let's dive into just the no authentication option. This is conceptually the easiest option, but can carry risk if you're not ensuring that the data that is being requested is sensitive or important here. So with the no authentication option, shockingly, authentication is not used. So anybody with the API URL can make a request. You need to really ensure that no sensitive data is available. So any API that's being built for a corporate purpose or gatekeeping any kind of sensitive information really needs to have authentication set up as a default when you move forward. Now, let's talk a little bit more about the flow model of using users and roles here. So when you use an authenticated request, and if I jump back here a couple of slides, what that means is your endpoint has an authenticated setting set that requires authentication to access your data. It leverages the FME Flow users and roles setup. And so you use the existing permission system in FME Flow to be able to better manage access to your endpoint. So anybody can make an access to the API URLs, but they need to have valid credentials. And I'll also highlight in a moment what that means. This is the easiest way to sort of secure your endpoint to help gatekeep the sensitive information to those who are allowed to have access to it. And so authentication in data virtualization is quite simple. At the endpoint level or even at your entire project level, you can control who is allowed to interact with your endpoints. You can see in the screen grab here, the endpoints that have authenticated or unauthenticated access, and then which user roles or which users are allowed to access these endpoints. The important piece here is that users and roles have to be maintained and managed for users to be able to access these endpoints, of course. So moving into some additional notes here, when you build a project using the FME roles and users, you end up working with a parent-child relationship of accounts. So you would build yourself an account, like a parent account, for example, that has the ability to create additional users, create additional tokens. And so you can actually build a project that creates users in FME Flow, creates API tokens for those users, and allows then the end users to authenticate themselves in a project. So we have a couple ways of doing this here. The easy ways a user logs in, they can use the parent set of credentials for everything as part of the header for subsequent requests. The problem is you don't know who that user is necessarily. And so that's where you use this parent account, generate an API token for the end user. You return that token to the end user in the web application or the tool that you're building. And you save that as a cookie or save that as an environment variable and use that for the subsequent requests so that the individual requests being made by the user are being done under their own name here. Authentication using the FME flow model is pretty straightforward as well. When you're making requests to a data virtualization endpoint, you've got three different ways you can pass through the authentication components here. So you could use a header with the username and password encoded. My preferred method is the second option here of generating an API token for each user and then passing that through as part of the header. Or you can take that token and also pass it through as a query parameter when making these requests. And so every time you make a request, you pass through the token or the username and password, and the data virtualization API will know who you are and that you're allowed to have access and allow you to then trigger the workspace that is connected to your endpoint. There's a lot of nuances that come with working with authentication and the flow model, and there's no single perfect method of doing it. It really depends a lot on the project and the processes that you're working on. We do have some resources around using authentication in data virtualization linked here, and we'll send the link out in the chat as well in just a moment. That will allow you to kind of take a deeper dive into some of the components around it. So we have a third method here, and this is a bit of a hybrid approach to the concept of authentication. And this is where you handle the authentication in an FME workflow instead of the data virtualization endpoint checking who you are and that you're allowed to do it. You do that on your own in a workflow afterwards. And so what ends up happening is you create a request or you go to a URL for a data virtualization endpoint, and it's technically set up with no authentication. You are trusting that every request is good and it's going to go through to the workspace. What then happens is in the workspace that you use for each of your endpoints, you do your own custom steps to check and decide if this user is allowed to do what they need to do. This does add a few levels and layers of processing that needs to happen, and we'll show a couple examples in a moment here. And it's also important that you handle your return. So you're no longer just returning a yes, okay, here's your data message, but you also have to handle the messaging that comes around to a user being unauthorized. For example, returning a HTTP 401 instead of a 200 in terms of the headers that you use. So here I'm going to show a quick example of what it takes to do a custom authentication. And this is initially what was used in my map travel project. I have since converted it over to use the flow model, but I wanted to show this because it allows you to have a bit more finesse and control over what you're showing. In this workflow, you're basically taking the token that's part of the header, and I, in my case, have created a custom transformer that goes and checks my database to ensure that the user is known and is a valid user. And all I'm doing is taking the token that is passed through, and I'm checking my database and seeing, does that token exist? If so, okay, great, returns a match and allows the rest of the data flow to continue with all the other pieces, building the JSON and returning the output. And so top output, you can see here, everything was great. It does the insert into the database and returns the valid response. The second output here was the output of the request to check to see that your user was valid, and it wasn't, so it's returning a 401, or if there was no header, it returns a 400. So you do have to handle those requests more cleanly and more explicitly in each workflow, rather than letting data virtualization do the work here. So we talked a whole lot about authentication, knowing who you are, validating the identity of the user, that you're allowed to actually do the work. We'll talk just really quickly here about authorization. Authorization is a much more nuanced topic here, and that determines what actions or resources that the user is permitted to access. And so, like I said, it has different facets for every company, every project, every workflow. It means different things to different people. And this is really where your business logic comes into play. So you can use your FME Flow user roles, for example, to determine what users can do in terms of actions. But if you need more granular control, what fields are they allowed to update, or what rows can they have access to? You need to look at incorporating that into your individual endpoints or workflows that are generated for them. And that comes down to, what I'm showing here is an example, making sure that users are allowed to do the specific actions that you're allowed to do in the workspaces. That's really kind of a high level look into authorization and authentication with data virtualization. It is a bit of a complex topic, but we've done a really good job, I feel, in implementing an easy to use approach. By using the flow user model and the roles model, you can eliminate a lot of the overhead and headaches that come into managing APIs in general, again, without having to write a line of code. So with that, I'm going to pass the reins back over to Rylan here, who is going to talk a little bit about what's new and coming.
Awesome. Thanks, Nick, and thank you, Dennis. Those are some excellent examples of exploring data virtualization in a little bit more detail. So let's take a look at what's new and what's just around the corner. Now, I felt compelled to mention this because after we announced data virtualization at the peak of data and AI, this quickly became the most requested feature, and I'm excited to say it's already here. FME Flow now caches results for unique combinations of query string parameters. So if your API uses parameters like status or limit, FME will store and reuse those responses to improve performance. It uses the same caching configuration that you can already define at the endpoint or API level, so there's nothing new to set up. Again, this came with the launch of data virtualization in 25.1. This upcoming feature is all about flexibility for more advanced API designs. You'll soon be able to define complex JSON structures directly within FME, like nested objects, arrays, or even schemas within schemas. It works whether you're creating an API from scratch or importing an existing open API definition. This one's coming in FME Flow 25.2, and it really opens the door to more enterprise-level API design. APIs often need to support a wide range of content formats, and now you'll have full control over that in FME. We're expanding the list of predefined content types that you can choose from, and we're also giving you the ability to manually add custom MIME types when needed. That means better alignment with your existing systems, more accurate, standards-compliant API docs. It's especially useful for teams working with external API consumers or integrating with strict specifications. This feature is all about efficiency. For APIs using asynchronous processing, we're introducing support for long polling, so you can reduce the load from constant status checks. Are you done? Are you done? By adding these parameters to your requests, FME can wait and respond only when the job is complete, cutting down on polling frequency and network traffic. It's supported across all workspace endpoints where async processing is enabled, and it's ideal for more scalable, performant API integrations. Again, this one's coming your way in 25.2. This is another step forward in making APIs more dynamic and event-driven. With callback URL support, you can configure a response from one API endpoint to automatically be sent to another endpoint once the job is complete. It's ideal for chaining together data virtualization endpoints or building more responsive data flows. In the first release, you'll be able to select from other defined endpoints, and we're already planning on support for setting to automations or any external URL. The UI you see here is still in progress, so expect some refinements. I guess that goes for everything that is coming soon in 25.2. So if you're interested in testing this out once 25.2 betas are available, did this or any of the other features, please get in touch as we'd love your feedback. So to recap, if you're new to data virtualization in FME, start with templates available on FME Hub or by importing an open API specification for an existing API. What we've shown today is how data virtualization helps you solve real problems, whether it's building standards-based APIs with the OGC templates or securing access with authentication and role-based control. Our advice is to define your endpoints early, test them. That foundation makes it easier to iterate and scale later on. And most importantly, keep letting us know what you need. Your feedback is driving these improvements from caching, callbacks, and long polling, complex schemas. We're just getting started with data virtualization. We can't wait to see what you build with it. And all your feedback is so valuable. As we wrap up, I want to leave a quick snapshot of the scale and support behind the FME platform. Safe Software has been solving data challenges for over 30 years with more than 25,000 organizations using FME around the world. We have a great global community, over 30,000 users across 128 countries, and a trusted partner network with over 140 certified service providers. So whether you're just getting started or building enterprise scale APIs with data virtualization, you're in good company and you're not alone. We talked a lot about APIs, automation, security, but at the core, what it's all about is empowering you to work with all your data, no matter where it lives or how fast it moves. FME supports all data velocities, from batch jobs to real-time, connects across any environment, cloud, hybrid, edge, works with every data type, structured, unstructured, spatial, and beyond. And as AI becomes more embedded in our workflows, FME is ready. Whether you're using OpenAI, Google Gemini, Amazon Bedrock, or something else entirely, FME helps you bring it all together. All data, any AI. That's the future we're building toward, and we're so glad to be building it with you.
All right, fantastic. Thank you, Rylan. So from here, I will take us through a few resources. This is a good final reminder that if you do have any questions top of mind from the content that was presented today, please get those into the questions tab because our live Q&A will be in just a couple of minutes here. So we do have some data virtualization specific resources, including the processes and features API templates. We've got them linked here. I will actually also drop those into the chat so you have those easy to access. We hope you can make a lot of use of those. Yeah, I'm not sure if anyone on the team has any other notes on these resources.
Yeah, those are the first bits of content we have available in our FME community. We're looking to produce a lot more material. If you're working with data virtualization, you find anything particularly challenging, let us know. That will help inform us of what would be most valuable to create next.
Awesome. Yeah, absolutely. Okay, so also I do want to highlight that we're all about free resources here at SAFE. We're home to instructor-led free training at our academy and our webinars. We have lots of upcoming exciting webinars. Check those out, and then hundreds available on demand. You can use the search bar depending on what you are looking to learn more about. In terms of next steps here today, beyond making use of those templates and resources, feel free to contact us, info@safe.com. We'd love to chat about anything data, or take our accelerator course if you are just in that exploration stage, learning more about FME. It's 90 minutes free of charge and a great place to learn the basics of FME. Claim your community badge as a thank you for joining us today. If you're a member of the FME community, we have a badge code that you can redeem there.
Awesome. Thank you, Elizabeth. We'll now be moving on to the live Q&A portion of today's webinar. And yeah, we just have Nick joining us today. Unfortunately, Dennis and Rylan couldn't be here today, but yeah, I'm sure Nick will answer all the questions that we have come in.
Yeah, so we've had a couple of light questions in the chat today. The one thing I really want to highlight is we've done a lot of work on the resources that are available in our community, in the knowledge base, and in our documentation around what you can do with data virtualization. And there's some really, like I'm saying, really good resources available. And
some interesting new things coming down the pipelines over the next couple releases to make the experience even more successful for you. We've had quite a few really solid examples of great use of data virtualization with our customers, and it's turned into be a real powerhouse feature for Flow. And one of the sort of interesting things about it is you really can do anything with data virtualization, just like you can do anything with Flow and Form and all of our products. And it's really exciting to see how it's being used and integrated, like the example we had today with from Terra. There was a couple questions in the chat about sort of the authorization workflow. There's some good points in our community. I'll see if I can dig up the links and send those out that talk about that a little bit. But the great thing about Flow and data virtualization, of course, is you can do it any way you need to as well, in terms of integrating authentication and looking at pieces like that and integrating with Flow's APIs, for example, to do user authentication, like I was trying to touch on today. But I think we did such a good presentation that there's not too many other questions that are lingering so far. But I'm always happy to answer any more as they come in and afterwards as well.
Yeah, for sure. Yeah, I think the webinar itself was really informative, so maybe it left some people speechless.
I have that tendency.
No worries. Yeah, is there anything else you wanted to highlight, Nick? Or
yeah, just say if there are any other questions or you need a bit more help in getting up and running with data virtualization, the community is a great place to start. Post a question. Our team is super knowledgeable, and we will jump in. Just had a question around dedicated engine for running the API with Flow. Nope, it'll use the existing queues and engines that you have, just like any other job that's running, and you can dedicate queues to certain API tasks, but it doesn't lock up a dedicated engine, like for example, streaming, because of the nature of how streaming works. So it's still quite flexible in that regard.
Awesome. Yeah, well, thank you so much to everyone for attending our webinar today. We'll leave this running for another 5 minutes, like I mentioned, so you can save out any links that were shared out in the chat or drop in any last minute questions. If we didn't get to your question, we will be sure to follow up with you after the webinar. But if you do have a moment just to fill out our webinar survey, we appreciate any feedback on these sessions. But yeah, thank you so much to everyone for attending.